Scientists have asserted in a daring statement that they have discovered a brand new planet unlike any other known to humanity. This momentous disclosure has sent waves through established researchers, starting a flood of energy and theory. This information has put NASA, a respected organization known for its significant contributions to space exploration, front and center. The planet in question is remarkable not only for its size and peculiar location in the universe but also for exhibiting a phenomenon that has experts in awe: light that appears to be artificial emanating from the planet. This disclosure raises significant issues. Could we be on the cusp of revealing mysteries that might change how we interpret the universe? Could this enigmatic light serve as a warning or beacon that other planets may have intelligent life? The repercussions are staggering, and as we investigate NASA's amazing findings, we may soon come face to face with facts that have the potential to alter our perception of reality itself. In 2007, NASA set out on a mission that would further solidify its heritage as a trailblazer in space exploration. The Dawn spacecraft, a design wonder equipped with 3 cutting-edge ion engines, was launched with a single objective: to investigate some of the most baffling objects in our solar system. The first step on Dawn's journey was a 14-month investigation of Vesta, the second-largest asteroid in the asteroid belt. The information and images that Dawn sent back to Earth shed new light on this enormous space rock, which had previously been shrouded in mystery. The findings of the spacecraft revealed a world of astonishing complexity with a geologically rich surface that spoke of ancient collisions and cosmic forces that gave it its current shape. However, Vesta was only the start. Dawn's mission was by no means finished. The spacecraft was given the even more ambitious task of taking a close look at Ceres, a dwarf planet, after it had completed its in-depth investigation of Vesta. This progress marked a critical achievement in space investigation. Dawn was able to escape Vesta's gravitational pull and set course for Ceres, thanks to the ion engine's gentle but constant thrust, a feat that conventional chemical propulsion systems would have found impossible. Dawn was able to travel a great distance thanks to its slow and steady travel, which eventually placed it in a stable orbit around Ceres, where it would begin the next phase of its mission. As the largest object in the asteroid belt, Ceres, which was discovered in 1801 by the Italian astronomer Giuseppe Piazzi, holds a special place in astronomy history. Initially celebrated as the smallest known planet, Ceres was renamed in 2006, further fascinating researchers and space experts alike. Ceres is not only the largest but also the most massive object in the asteroid belt, with a diameter of about 950 kilometers. Researchers have long been intrigued by its distinctive features, which set it apart from other celestial bodies in the area. The scientific community eagerly anticipated the first detailed images of Ceres' surface as Dawn approached this mysterious world. Every expectation was surpassed by what they discovered, particularly within a vast crater known as a crater. The images revealed a surface dotted with bright spots. Scientists were immediately captivated by these bright spots that were dispersed like beacons across the dark, rocky terrain. This disclosure ignited a flood of hypotheses. What might these brilliant spots be? Prior to Dawn's mission, the Hubble Space Telescope's best images of Ceres were blurry and low resolution. These new high-resolution images promised to reveal secrets that humanity had been unable to discover for centuries. One of the critical targets of the Dawn mission was to improve how we interpret the arrangement of planetary bodies, especially the role water played in the development of planetary bodies. Bright spots on Ceres appeared to be made of highly reflective materials, possibly salts formed when water was sublimated. A groundbreaking theory emerged as a result of this revelation. Ceres might be experiencing cryovolcanism, a process in which volcanoes erupt with water or brine rather than molten rock. This possibility suggested that Ceres might be active geologically, which contradicted previous notions about this dwarf planet. As scientists continued to examine the bright spots, the mystery grew more complex. What precisely were these lights, and what did they reveal about Ceres' geography? Might they show progressing topographical cycles or perhaps something even more exceptional? These inquiries fueled another wave of exploration as researchers tried to unravel the secrets of this distant world. Ceres sets itself apart from other asteroids in the belt by its size and mass, as well as by its unique composition and the potential presence of water and ice. Unlike ordinary rocky space rocks, Ceres has a composition more similar to a comet, suggesting it could hold fundamental clues about the early solar system. The Dawn spacecraft finally made it to Ceres in early 2015, marking a significant milestone in space exploration after a 2-year journey through space. In stunning detail, the pictures it sent back showed a world that had been hidden in shadow. The first images of Ceres revealed a surface that had been shattered by impacts. However, the bright spots scattered throughout this alien landscape were what truly piqued the interest of space enthusiasts and scientists. As the quality of the pictures improved, researchers began to shape hypotheses about the origins of these spots. Could they be something even more unusual, or were they simply ice patches that caught the sun's rays? Hypotheses ranged from mineral deposits to indications of cryovolcanic activity, each offering an enticing look into the secrets of Ceres. Closer review uncovered that the most brilliant spot was not a lone component but rather a bunch of particular spots. The most popular theory was that these were salt deposits formed when water sublimated. This proposed that Ceres, as opposed to past assumptions, could still be geologically dynamic, with processes capable of bringing water or briny solutions to the surface, where it rapidly dissipates, leaving behind brilliant, reflective deposits. These discoveries challenged how we interpret Ceres, depicting a dynamic and complex world far more captivating than anyone had envisioned. The possibility that Ceres could harbor pockets of groundwater or brackish water raised significant questions about the potential for life in our nearby solar system. Ceres is a world of contrasts, an icy dwarf planet with a surface that is both rocky and porous. Ceres stands out because of its distinctive composition in contrast to the majority of asteroids in the belt, which are primarily composed of rock and metal. It has a structure that is less dense than that of its rocky neighbors because its surface is a combination of water ice and hydrated minerals like carbonates and clays. This structure suggests that Ceres contains a lot of water trapped inside its surface layer, making it more like a comet than a common space rock. The dwarf planet Ceres is thought to have a unique internal structure with a mantle and a core rich in water ice that makes up about half of the planet's volume. This mantle is likely a combination of rock and brine surrounding a core that might be made of denser materials like silicates. The presence of such a large amount of water ice on Ceres suggests that the planet might have once hosted liquid water, particularly if its core was warmed by radioactive decay during its early history. This internal structure sets Ceres apart from its space rock neighbors, raising intriguing questions about its geological activity and the role water has played in its development. However, Ceres has more surprises in store. This dwarf planet may have formed in a much cooler region of the solar system before migrating inward, as evidenced by the ammonia clays found on its surface. The presence of ammonia could lower the freezing point of water, possibly supporting the presence of surface saline solutions. Not only do these findings shed light on Ceres's composition and history, but they also illuminate the larger processes that control the formation and evolution of icy bodies throughout the solar system. Cryovolcanism, an intriguing and captivating geological process, adds another layer of interest to Ceres's story. Cryovolcanoes on Ceres release substances like water, ammonia, or methane. In contrast to the usual eruption of molten rock on Earth, cryovolcanoes are mechanisms by which these substances, capable of existing as liquids or gases in the extremely cold environments of space, are expelled from the planet's interior. The salt water rapidly sublimates when it reaches the surface and is exposed to the vacuum of space, leaving behind salt deposits that are reflective. The bright spots that have captivated scientists and the general public are made up of salt residues. The most well-known of these bright spots can be found in the Equator crater, specifically in the Equator 5 region. This region has become a focal point for scientific examination because of its high reflectivity and the intermittent clouds observed by the Dawn spacecraft. These clouds are believed to result from water sublimation, suggesting that cryovolcanic activity might still occur or has occurred recently on Ceres. Ceres is home to several other bright spots, each with its distinct characteristics. In addition to Equator 5, the dispersion of these spots across the dwarf planet's surface suggests that cryovolcanism may be more widespread than previously thought. The presence of these brilliant spots challenges the earlier assumption that Ceres was a geologically inert world. Instead, they highlight its dynamic nature, revealing a planet that is still evolving with active processes that continue to shape its surface. A wide variety of Ceres's surface features began to emerge as the Dawn spacecraft acquired more in-depth images. The dwarf planet's surface is specked with craters, each telling a piece of Ceres's long and tumultuous history. Scientists can learn a lot about the processes that have shaped Ceres over billions of years from these craters and the bright spots. We are reminded of the vastness and complexity of our solar system as we continue to investigate Ceres and decipher its mysteries. Every revelation brings us one step closer to understanding not only Ceres's history but also the broader processes that have shaped the solar system. With its groundbreaking findings, the Dawn mission has challenged our understanding of planet formation and the possibility of life in the